Lesson 2-4, solving equations with variable on each side. Our essential question today is how do you solve a multi-step equation? Multi-step. So we've solved one-step and two-step equations and equations with a variable on each side. Now we're just going to solve multi-step equations. So they could have 2 or 3 or 4 steps, maybe even more. Our steps. Step number 1, it is absolutely important for you to distribute when you see parentheses. Multiply and distribute, and do that first. It's kind of like with PEMDAS. With PEMDAS, you start with parentheses. When you see parentheses in an equation, you need to start there. Then, step 2 says, combine same side like terms. So add or subtract them if they're on the same side, depending on what signs are in front of them. Then step 3 says get the variables on one side, and step 4, solve the remaining 1 or 2 step equation. So there are a lot of steps. The important thing is to distribute first, then the rest of the steps are a little bit negotiable. So sometimes you can do them in a little bit different order and it doesn't matter, but the distributing has to happen first, okay? All right, so solve this equation. So I'm going to draw my train track, and we are going to start by distributing. Remember that when you distribute with a negative number, you really want to be careful with your signs. Negative 2 times 3x is negative 6x. And negative 2 times negative 6 is positive 12. A negative times a negative is a positive. Now, I can circle my variable part, subtract the 12 on both sides. Negative 12 minus 12 is not 0. Negative 12 minus 12 is the same as negative 12 plus another negative 12. It's negative 24. Then if I divide by my negative 6 on both sides, x equals positive 4. Our next one, a little bit more complicated. We're doing some distributing on each side. So on the left-hand side, 5 times x is 5x, plus 5 times 1 is 5. On the right, negative 2 times x is negative 2x. Negative 2 times negative 6 is positive 12. Now, we have variables on each side, so remember that I like to eliminate the smaller one. The smaller one here is negative 2x, so I need to add 2x to cancel it out. So 5x plus 2x is 7x, plus 5 equals 12. Now I've got my variable part. I can subtract 5 on both sides. So 7x equals 7, and then divide by 7. 7 divided by 7 is 1, so x equals 1. So I distributed first on each side, then I needed to get my variables to one side in order to isolate it and keep solving. Okay, this next one, what we see is a little bit different. We see on the same side like terms. So we need to combine those like terms first. They're both positive, so 6x combined with 2x is 8x. So this is different from when we're eliminating a variable because we want them all on the same side. They're already on the same side. So you just have to combine them together and be careful with their signs. Now my variable part is 8x. This positive 4 I would need to subtract to get rid of it. 4 minus 4 is 0. So 8x equals negative 24. Divide by 8 on both sides. And x equals negative 3. Our next one, trickier because we have a negative 4x and a negative 2x. If you combine those together, you will get negative 6x. So negative 6x minus 1 equals negative 55. It does not matter the order that I write the negative 6x and the negative 1 in. I could have kept it in the order that it was, where it was negative 1 and then minus 6x. That means the exact same thing. Circle my variable part so that I see that I need to add 1 on both sides. So negative 6x equals negative 54. Be careful with those signs. And then divide by negative 6. X equals positive 9. Now we have a couple of problems that are a little bit different. These are geometry applications, and they're really important because when you're in geometry, you'll solve a lot of these kinds of problems. So find the value for x that makes the perimeter of each figure equal. Perimeter. Perimeter is the distance around something. So we need these perimeters to be equal, so I'm going to have the triangle, and that perimeter has to equal the rectangle. Perimeter means adding together all of the sides. So if I add together all of the sides on the triangle, I have x plus 1, another x plus 1, and 3x plus 5. If I add together all of the sides on the rectangle, I really need to think about it a little more because they're only showing me 3x minus 5 and then x plus 4. So it's a pretty common mistake for students to stop right here and forget that there are actually 4 sides on that rectangle. So I need another 3x minus 5 and another x plus 4 so that I've got all 4 sides. Now look at this equation. We are going to have some combining to do first. So I'm going to combine my like terms over here. 1x plus 1x plus 3x is 5x. Then 1 plus 1 plus 5 is 7. So 5x plus 7 represents the perimeter of the triangle after I've combined my like terms. Now I'll do the same over here. 3x plus 1x, that's 4x, plus another 3x and another 1x, that's 8x. Negative 5 plus 4 is negative 1. So negative 1 combined with negative 5 is negative 6, plus 4 is negative 2. So you've got to be careful with your signs. Now, let's solve it. So I'm going to subtract away my smaller variable. My 5x is smaller. So that leaves me with 7 equals 3x minus 2. Then I can circle that variable part, add the 2 on both sides. So 9 equals 3x, divided by 3, and 3 equals x for my answer. So did I answer the question? Yes. Find the value for x that makes the perimeter of each figure equal. 3. Can I plug it in and check it? Absolutely. 3 plus 4 is 7. 3 times 3 is 9. 9 minus 5 is 4. So if I add all of these sides up, 7, 7, and 4, I get a perimeter of 22 units. If I plug in my 3, I get 4 and 4. 3 times 3 is 9. 9 plus 5 is 14. So if I add these together, 14 plus 4 is 18 plus 4, perimeter 22 units. So my answer is correct. Okay, our last example. Find the value for x so that the figures have the same area. Well, now we're talking about the area, and the area of a rectangle is length times width, or base times height. So, and either way, it could be base times height or length times width, means the same thing. So I am going to have to set this up. We've got 2 rectangles. So the first rectangle, if I do length times width or base times height, it would be 2 times x plus 7. And then for the second one, it would be 9 times x, like that. So I need to distribute. 2 times x is 2x, plus 2 times 7 is 14, and solve this. I've got a variable on each side, so I'm going to subtract the 2x, my smaller one. Remember, I wouldn't want to subtract the 9x because it's all alone anyway. So 14 equals 7x, and I can divide by my 7. So x equals 2. If I go back to my original problem, 2 plus 7 is 9, so the area 2 times 9 is 18 units squared. And then if I plug in my 2 for x, 2 times 9 again, 18 units squared. So my answer is correct. Find the value for x so that the figures have the same area. X equals 2. You should be able to write a summary now on how to solve a multi-step equation. Please make sure you use complete sentences, and please make sure you think about all of the different types of situations that you can see in a multi-step equation.